Good morning. So, we are discussing the subject signals and systems. In the last few classes, we talked about the introduction of signals, introduction of systems, few special type of signals already we talked about. Today I am going to discuss about the classification of signals. We have to know few classifications of signals because these classifications are very important. Number one, deterministic and random signals. Number two is periodic and non-periodic or periodic and aperiodic signals. Next one is even and odd signals. Fourth one is energy and power signals, and fifth one is causal, anti-causal and non-causal signal and non-causal signal. So, these 5 classification we should know. There may be another few classifications of signals, but these 5 are most important we should know, and rest of the classifications we will talk about day by day. Now first one is deterministic and random signal. So, what is deterministic signal and what is random signal we have to know. Deterministic signal is that signal which is completely specified by the mathematical equations and waveform. It should have a specific mathematical expression. It is we can express it with the help of mathematical equation, and it have a particular waveform. But in case of random signal, we cannot specify it with the help of mathematical equation, and it do not have any special representation or waveform by which we can represent this random signal. So, what is deterministic signal? What are the examples of deterministic signal? Those signals, basic signals which we already discussed, they are the deterministic signal, because all of them we can represent all of them with the help of mathematical equation, and we can draw their waveform. So, unit step, the triangular function, rectangular function, sinusoidal function, they are the deterministic signal. But in case of random signal, the most common example is the noise signal. So, noise signal we cannot express noise signal with the help of mathematical equation, because it is its characters is unpredictable, it is random in nature, and as well as there is not any particular representation of noise signal. So, if we talk about the deterministic signal, so example of deterministic signal, it is very obvious, that is unit step or sinusoidal etc. So, it should have specified it has a specified representation. So, unit step we know we can represent unit step by this waveform. Okay, this is t is equal to 0, this axis is t, this is ut, okay, and these values is equal to 1. So, it is a we can represent with the help of equation. So, ut is equal to 1 for t greater than 0, it is equal to 0 for t less than 0, already we discussed in our previous classes. So, there is particular mathematical equation, and there is particular waveform. So, this is deterministic signal. In the same manner, there is sinusoidal sinusoidal maybe sine signal or maybe cosine signal. So, we can represent, so this is the sine wave, and we can represent with the help of equation xt is equal to a sine 2 pi ft. This is the mathematical equation, and this is the corresponding waveform. So, deterministic signal and random signal. Deterministic signal, in case of deterministic signal there is particular mathematical equation, there is waveform, but in case of random signal what will happen? The example of random signal is noise. It is very random, its character is random in nature, that is we cannot express it with the help of mathematical equation, or there is not any particular waveform for it. So, example of this is deterministic, this is deterministic. An example is noise signal. that is random. So there is no particular representation of noise signal. Okay. So this is about the first classification, deterministic signal and random signal. Now I will be talking about the second one, that is periodic and non-periodic signal, or periodic or aperiodic signal. Okay. So periodic signal is that signal for which a particular pattern of the signal, repeats over a particular time. Okay. So a periodic signal is that signal where a particular pattern of the signal repeats over a particular time, over a particular interval. And in this case, if xt is the signal which is periodic, then x small t plus interval t is equal to again xt, that is it repeats itself in that particular interval. Okay, where this t is known as, capital T is known as the fundamental time period. Okay. So as for example, let us consider sinusoidal signal. Okay. So any sine signal, this is sine signal. So from this point t is equal to 0 to this point, this particular pattern repeats every time, So a particular pattern which repeats a particular interval again and again, that is the periodic signal. In this case, xt plus capital T is equal to xt. Another example we can take, let us consider this one. Okay. So this is t is equal to 0, this axis is t axis, this is let us consider xt, and this is 2, this is 4, etc., etc. So from t is equal to 0 to t is equal to 2, this particular pattern, okay, repeats again and again. So from here again the particular pattern repeats again and again. So this instant 0 to t, this time period 0 to t, that is, this is the fundamental time period 0 to t. Okay. This interval 0 to t, the waveform in this interval repeats again and again, that is why this is known as periodic signal, where this pattern, this time period 0 to t, in this case it is known as the fundamental time period. Okay. In the previous example, here 0, this is 2 pi, time period is 2 pi. So in each 2 pi there is a repetition. So here fundamental period is 2 pi. Okay. Now in case of periodic signal, xt plus capital T, that is the fundamental time period, is equal to xt. Okay. And a signal which is not following this particular equation, or which where a particular pattern does not repeat, that is the aperiodic signal or non-periodic signal. So aperiodic signal, non-periodic signal is that signal which is not periodic. Okay. Now example of periodic signal, already I discussed. All the sinusoidal signal and exponential, complex exponential signals are periodic signal. So all sinusoidal signal, it may be sine wave, it may be cosine wave, all sinusoidal signal and all the complex exponential signals, they are the periodic signal. Now we may find that one periodic signal is given xt. Okay. It may not be periodic, xt is given, which consists of two part of the periodic signal. xt is given which is consist of two periodic signal. So xt is equal to x1t and x2t. x1t is periodic, x22 is periodic. x1t, for x1t time period is t1, for x2t time period is t2. Okay. So one signal is given which consists of two periodic signals, x1t and x2t. where x1t, time period of x1t is t1 capital T1 and time period of x2t is capital T2. Now what is the procedure to check whether xt is periodic or not? There is a particular procedure, that is a mixture of two periodic signal may be periodic or may be aperiodic. If time period T1 and time period T2, that is two parts of the signal, if their ratio is rational number, then we can say that this xt is periodic signal. So what we have to check? We have to first find out the time period of first part x1t and time period of second part x2t. Let us consider the time period of first part is t1, time period of second part is equal to t2, and now we have to find out the ratio of t1 and t2. If this is rational number, then xt is periodic signal. Now what is the fundamental time period of xt? The fundamental time period of xt is capital T, which is the LCM of T1 and T2. Understood? So this is you may find few mathematical problems where you can see that a given signal there are two parts and both the parts they are periodic. First part, the time period of first part is T1, time period of second part is equal to T2. So how to check whether xt is whether the overall signal is periodic or non periodic? Find out T1 and T2, take the ratio. If it is rational number, that is T1 by T2 is rational number, then obviously xt is periodic signal. Now how you can find out the overall time period, that is what is the time period of xt given signal? The LCM of T1 and T2. Now let us consider one example. As we are talking about periodic and non-periodic signal, let us check whether a signal is periodic or non-periodic. Okay, consider one example. Xt is 2 cos t by 4. One signal is given, xt is 2 cos t by 4. Check whether this signal is periodic or non-periodic. If periodic, now find out the fundamental time period. Okay. As we know, all the sinusoidal signals, it may be sine signal, it may be cosine signal. Okay. Not only that, all the complex exponential signals, they are also periodic. Okay. So here xt is 2 cos t by 4, so it is cosine signal, so it is obviously it is periodic signal. Now no doubt, now we have to find out the fundamental time period. We know the fundamental equation for this. Standard equation is a cos 2 pi f naught t. Okay, this is the standard equation of cosine wave. Now compare the given equation with the standard one. This is the amplitude, a is equal to 2, if you compare it. So a is equal to 2 pi f t, 2 pi f naught t, this is equal to t by 4. Okay. Now from here you can find out 2 pi f naught, this is equal to 1 by 4. If you compare this given equation with the standard one, then we can get this. So from here you can find out f naught is equal to, what is f naught? 8 pi f naught is equal to 1. So f naught is equal to 1 by 8 pi. Okay. So obviously the fundamental time t is equal to 1 by f naught, this is equal to 8 pi. This is the fundamental time period of the given signal. So xt is given as 2 cos t by 4, and the procedure to check whether this signal is periodic or non-periodic, and if it is periodic, then what is the time period of the given signal. As we know, every sinusoidal signal is periodic signal, here it is periodic signal, no doubt. Now this is the procedure to find out the fundamental time period, t is equal to 8 pi. Okay. Let us consider another example. xt is given 2 cos 2 pi t by 3, 3 cos 2 pi t by 7. few minutes ago I talked about this, a mixture of two periodic signal. Here it is, this is the numerical example. xt is given as it is a two part of periodic signals. As we know, cosine signal is periodic signal. So xt is a combination of x1 and x2, where x1 is 2 cos 2 pi t by 3 and x2 is 3 cos 2 pi t by 7. So we have to check whether this signal is periodic signal. If it is periodic, then what is the fundamental time period? Okay. Now our first duty is to find out the fundamental time period of the individual part. So first we have to find out the fundamental time period of x1. So if like the previous procedure, if I compare this signal with the standard one, this is the standard signal, if I compare this, then I can find out again a is equal to 2 and 2 pi t by 3, this is equal to 2 pi f naught t. Okay. So 2 pi f naught t, this is equal to 2 pi t by 3. Okay. Here f naught, I am instead of f naught I am writing f1, as it consists of two part and I represented this is as x1 and this is as x2. I am considering the fundamental frequency of first part x1 is f1 and fundamental frequency of x2 is f2. So from this equation, after comparison we can find out f1, that is fundamental frequency of the first part, is equal to 1 by 3. So time period t1, fundamental time period t1 of the first part is equal to 1 by f1, that is equal to 3. 3 is the fundamental time period of the first part. Now consider this second part. So second part is 3 cos 2 pi t by 7. Compare this signal with the original, that is standard one, a cos 2 pi f naught t, where in this case f is equal to a is equal to 3, amplitude is equal to 3, and 2 pi t by 7, 2 pi t by 7 2 pi f2 t, this is equal to 2 pi t by 7. So if I compare 2 pi f2 t is equal to 2 pi t by 7. So from there f2, fundamental frequency of the second part, is equal to 1 by 7. So fundamental time period t2 is equal to 1 by f2, that is equal to 7. Okay. So now the two part of the given signal xt, first part, the fundamental time period of the first part is 3 and fundamental time period of the second part is 7. Now find out the ratio of t1 and t2. If it is rational number, then signal xt is periodic. If it is not rational number, then signal x2 is not periodic. So t1 and t2 is equal to 3 by 7. Obviously this is rational number. So as t1 by t2 is 3 by 7 and it is a rational number, then xt is periodic signal. Okay. So this is the procedure when a signal, given signal is consist of two or more periodic signals, then how to check whether the original signal is periodic or aperiodic. So this signal is periodic. Now as we know this signal is periodic signal, now we have to find out the fundamental period. Obviously, what is the fundamental period of xt? Fundamental period of xt is the LCM of t1 and t2, LCM of the fundamental time period of the two parts, that is LCM of fundamental time period t is equal to LCM of t1 and t2, that is equal to LCM of 3 and 7. So this is equal to 21 obviously. Okay. So fundamental time period t of the given signal is 21 second. So this is the procedure to find out the fundamental time period of a signal which consists of two periodic signals. Got it? Thank you.